We are in Algebra 2. We are doing the dividing complex numbers homework. The general idea behind each of these is make sure there's no imaginary term in the denominator with whatever trick you can use, and make sure your fraction is simplified. So in the first one, we have a really easy problem that we might need some reviewing on since we did it so fast in class. The general idea here is for every single one of these problems is you're always multiplying by the same thing over the same thing, because then essentially you're just multiplying by 1. Multiplying by 1 doesn't change the nature of this number. So the thing that you're going to multiply by is I, because if you multiply by I times I, we'll deal with the numerator in a sec, is I squared, meaning that you've gotten rid of the imaginary term because I squared is just -1. So therefore, we'll have a -1 in the denominator. And you can't just willy-nilly multiply the bottom by something and not the top, because then you're not multiplying by 1. You need to multiply by the same thing here and here. So the numerator also needs to be I. And if that's the case, you need to distribute this I into each of these two numbers. So I times 5 is a 5i, and then this I times 2i is a positive 2i squared. And oh, look, again, we have an I squared term. We know that the I squared term here will turn into a -1. So I really have a -1 times 2, which is a -2, and I have a 5i, so I can just rewrite the positive 5i. And again, this is not quite simplified, because whenever you divide by 1, ignoring the negative for a sec, you're just not supposed to write that. So I need to somehow divide u by a negative, divide u by a negative, and I get my final answer, which is a positive 2 minus a 5i, and I box my final answer. Let's try another one. Number 2 needs a new trick. So here's the trick for this one. If you multiply by the complex conjugate of the denominator, then it will get rid of the imaginary term. So in this case, you have a 1 and you still have an I. You still have these numbers, but you change the sign. If it's a minus, it turns into a plus, and vice versa. If it was a plus, then it would switch into a minus. That is what it means to be a conjugate. So I'm going to multiply by 1 plus I, and again, I can't just willy-nilly multiply that denominator without the numerator. I also have to do 1 plus I in the numerator as well, and I'm now just multiplying by number 1, not changing this number over here. All right, so here we go. Let's go ahead and write out the long way of the denominator. If I multiply 1 times 1, I get 1. If I multiply 1 times I get positive I. If I multiply negative I times 1, I get a negative I. Now, if I multiply negative I times this I over here, you get a negative I squared. Okay, denominator is all set up. Time for the numerator. And again, you're kind of doing the same thing, right? You're saying 3 times 1 is a 3. 3 times I is a 3i. Then you multiply positive 4i times 1, which is a positive 4i. And then finally, a 4i times an I is a 4i squared. And again, in both of these, I have I squared, which turns into a -1, I squared, which turns into a -1. And notice in the denominator, I have a negative, a double negative. Therefore, these are really plus. I'm going to go ahead and rewrite this as plus, plus. And oh, look at this also. So I have a positive I and a negative I. Those are opposites of each other, so they cancel each other out. And you're just left with the denominator of 1 plus 1, which is just 2. And that's nice because we're trying to get rid of the imaginary part. And look, there's no imaginary part in the denominator. Now we just need to worry about that numerator, and we're out of here. So what do we have up here? I have all of our real terms. I have a -1 times 4, which is a -4. And -4 plus 3 is a -1. So far, so good. What about our imaginary terms? We have a 3i and a 4i. That adds up to a 7i, and we're done. I just want to check really quickly. Can I divide the bottom by 2? Yes. Can I divide the top by 2? No. Okay, those are odd terms. So I can't simplify this fraction at all, and I can just box my final answer. Let's move on to the hardest of all of them. This is how we ended our day today. We need to, again, multiply by the complex conjugate. In this case, that complex conjugate, I still have an 18. I still have a 12i. You just copy down these numbers on the outside, and you change the plus sign into the opposite, which is now a minus, a negative. All right, so if I multiply the bottom by 18 minus 12i, I also multiply the numerator by 18 minus 12i. And we have a lot of math ahead of us, so get ready. Here we go. First, I'm going to do 18 times 18. You know 18 squared because one of your flashcards, right? 18 squared is 324. That's not how you write 324. 324 like this. And then I'm going to multiply 18 by -12i. Okay, so if you don't remember how to do that, let me give you a quick reminder. 18 times 12. I know that it's going to be negative because a positive times a negative is a negative. I know that there's going to be an I in it, so it's going to be negative something with an I in it. The question is, what is that number, that coefficient on the front? Well, to multiply 18 by 12. You add these up. 18 plus 2 is 20. And then you add on a 0. And then you add on together what 8 times 2 is, which is 16. So the answer is going to be 216i. That's our shortcut for multiplying the teens, anything between 11 and 19. All right, so we do the same thing again. We're going to kind of distribute here. What's a positive 12i times an 18? Ah, we just did that. That's 216i. Now it's a positive 216i in this case. And then finally, we multiply the 12i by a negative 12i, and a negative times a positive is a negative. I times I is an I squared, and 12 times 12 is 144. And we have the denominator. Holy moly. Okay, time to do the numerator, which is even more multiplication. Let's do 13 times 18. So 13 times 18, I don't know. I'm going to do 13 times 18. And again, I'm adding 13 and 8, and I get 21. And then I put on a 0, and then I multiply 3 times 8 is 24. I add these together, 234. So 234. Then I multiply the next one. 13 times, oh, that's the wrong one. 13 times negative 12i. So that's going to be a negative with something with an I in it. And I just need to do 13 times 12. So again, 13 times 12. If I multiply those together, I'm adding 13 and 2 to get 15. 15, add the 0. I multiply the 2 and the 3, and I get a 6. 150 plus 6 is 156. Nice. And then we move on to the next one. Negative 16i times 18. Well, I don't know. What is 16 times 18? Again, I'm doing that shortcut. You should be able to do this in your heads, but I'm just showing my work, right? I'm saying, yes, so 16 plus 8 is 24. 24, add on a 0, and then 6 times 8 is 48. So I say 48, and I add those together. This is 288, so plus 288i. Let me just check the sign here. I have a negative times a positive, and that is that's wrong. It should be a negative. There we go. Negative times a positive is a negative, and then I do my last term, which is a negative times a negative, which is a positive this last case. This is going to be multiplying this direction right here. I have a positive, something with an I squared in it, and I can see that because I have an I times an I, which is an I squared, and I just need to do 16 times 12. So I'm running out of scratch room. Let's go ahead and write 16 times 12. Again, I add these up. 16 plus 2 is an 18. Add on the 0. 6 times 2 is a 12, so I write a 12. This is 192 I squared. Whew, lots of multiplication. Now we just need to simplify. So I know that all of these I squared terms are going to turn into a negative 1 into a negative 1, which means the bottom here is really a plus because there's a double negative. This top one is now a negative 192, and I have a 234. Let's do that real term first. So what I'm really asking here is, what is 234 minus 192? I think that's right. I don't know how to do that, so I'm just going to add 8, and do, what is 234 minus 200? And that answer is a little bit, whoa. 304 plus 8, that's not right. I can say 234 plus 8 is 242. Okay, now I can subtract them. 242 minus 200 is 42. So I can say 42. And then next I need to add these two numbers together because they're both going in the same direction. What is this going to be? This is going to be negative 444? Is that many fours? I think so. Yeah, 444i. I think I did that right. If I'm making any mistakes in this video, and I do make mistakes, I'm human, I go fast, and I'm not perfect. No one is perfect. Please catch it and then log the extra credit when you come back in class. What about the denominator here? So I know usually what's supposed to happen is that these two middle terms are opposites of one another, so they cancel out. That means less adding for me. And then this last number should always be positive. It's not something that's gone terribly wrong. 144 plus 324, that's going to be 468, it looks like. That seems right. All right. So that's our answer. But I'm noticing that each of these numbers is divisible by 2. Is this divisible by 4? No. So I think at the maximum we can do is divide by 2. So let's go ahead and divide the numerator and denominator by 2 here. So to make this a 21 minus 222i all over 234. Whew. What a problem. I'm only like 60% confident that's the right answer because I did so much multiplication here. Please correct my work and let me know if I got it right the next time that we have class. That's it. I'll see you guys later.